So we're going to determine the 4 different equations for the periodic function shown on the graph below. Let's extract some important info first so that we can do that. So notice that this graph is being compressed quite a bit. One cycle goes from here, I'll use a different color. Let's use orange here. Goes from -1 up to the top at 1, all the way down to -3, and back to -1. So we have these points here, this guy, this guy, this guy, this guy, and this guy. So that's one cycle. And from that, I think you can read off some important info. For example, the period. Well, that's just going to be, if this is 90, each block will represent 15. That'll be 1, 2, 3, 4. So one period is going to be only 60 degrees. And the amplitude, okay, that's the distance from the middle to the top. So if you go from -1 to 1, that'll be 2. What else do we have? Phase shift, we're going to leave. The k value, or the equation of the axis, that's going to be over here. So -1, in other words, our graph, whatever it is shift down 1 unit. And our p-value. P-value is going to be 360 divided by 60, which gives us 6. Okay, so we are ready to fill in some of the information that we need for our equation. Let's start off with sine. So I'm going to have f of x equals 2, because that's our amplitude, times sine, bracket, my b-value is 6. I have x minus, we don't know the phase shift yet, then I have a -1 at the end. This is a good one actually, because remember, sine starts from the middle, right? Goes up, comes down, and goes back to the middle. It looks like there's no phase shift here because it is, we're not moving that graph left or right, which is good news for our equation because I can just erase this, 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 and then bring everything together. Let's bring this over. Let's bring this over. And let's bring this over. So there's your sine function. Very easy. Now let's look at negative sine. So I'm going to have f of x equals a -2, because it's a negative sine function, times sine 6x, phase shift, whatever it is, -1. So what is our phase shift? Well, let's go back to our original function. Remember, negative sine goes down first, then comes up, and then goes back down to the middle. So it's something like down, up, and down. You can see that this graph here has been, you can think of it, if this was the original, it's been shifted back 15 units to the left. In other words, I'm going to have +1.5 for my phase shift. Sorry, not 1.5, it'll be 30. So it'll be x plus 30 degrees. And that is our negative sine function. Next, let's look at cosine. So f of x equals 2 times cos of 6, x, whatever the phase shift is, -1. Cosine, if you recall, will start from the top. Now you can pick any top. Let's take this one here. Goes down and goes back up. So you can see that over here, okay, The top of the cosine graph has been shifted over to the right by 15 degrees. So I'm going to have a minus 15 over here in my equation. Final one. F of x equals negative 2, because we're doing a negative cosine, cos 6x, whatever the phase shift is, minus 1. So what is it going to be in this case? Well, negative cosine, let me just erase this, goes from the bottom and moves up. So it's like from down here, comes up to the top, and then goes back to the bottom. And that first point at the bottom there looks like it's 15 degrees behind. So it'll be plus 15 degrees. Anyway, these are all our 4 equations representing the sinusoidal function you see on your graph on the right. Every one works, but if I were to choose which one is best, I would say this. Again, because it avoids having any phase shift, which can only complicate equations.